A simple way to become a powerful programmer, or learning programming the right way. Let me tell you right here in the first paragraph. Use a slow computer. Slow computers are almost always single-board computers, little over the size of a credit card. They should come in a kit and cost less than $200. Please attempt to purchase from the company that actually makes the kit, as resellers may be artificially inflating the prices. You should do your own research, but the computer that comes to my mind is called the Raspberry Pi, because the kit ships with all the parts, including a keyboard and a mouse. More specifically, CanaKit Raspberry Pi 4 8GB Extreme Kit. This is priced at $169.95. I think this is somewhat fair for a full kit that gets a computer going. You will need a monitor. These go for about $70, but no more than $100. The Raspberry Pi 4 does support 2 monitors, but you don't have to get them both at once. But, the more room for terminal windows, the better. And of course, you can just connect the kit to your network as is, and then use a big computer to get inside the little one and do your programming there. When learning or just starting to get good at programming, you are faced with multiple ways of accomplishing a task. The Pearl monks often quote Larry Wall. Tim Toady, spelled TMTOWTDI, which stands for There's More Than One Way to Do It. While that is true in a broader context, to be good at programming, you have to choose one of the fastest ways to do it. Even more important than having a way to develop a nose for efficient programming by means of a computer that will tell you when you are wrong, is gaining this beautiful ability to see slow code just when you are starting out with your programming. What a marvelous invention! This ability to navigate the programming world not by listening to others, but simply listening to whether or not your little CPU fan comes on. More than that, you don't really need a teacher here. What could they possibly know that you can't know better by being efficient on a slow SBC, single board computer? And speed matters. While desktop computers are getting faster, the code that we write today is likely going to run on a starved virtual machine, at least during the build steps. And that will be probably over at some corporation trying to squeeze every cent for all the distributed code repositories. Their build systems is what gets you. Yeah, with all these super fast computers everywhere, your build system is still gonna be slow and charging you per second. While every second counts, it is the people who don't count them that really lose. An unoptimized, clunky, and confusing system, not written with efficiency in mind, is a ticking time bomb. Few extra equally inefficient additions will make the system come to a crawl if you are lucky. Mostly, it's game over. Rewrite your code and try again. You may be thinking to yourself that you can rely on benchmarking on a speedy system, but that is always a lie, especially when you work hard and are always short on time. A fast computer will constantly tempt you with shortcuts, or cake, as some call it. A slow computer is like having a responsible teacher staring at your every move. In closing, I will give you some examples of efficient code. Node streams, from the realm of Node.js, a modern JavaScript ecosystem for the server, allows you to process binary files in chunks. When working with a large video file, a slow computer will force you to stream the frames through your program one at a time. You will never load the whole thing into your memory. This applies to working with text-based data files as well. You will structure your text or JSON so that you only consume one line at a time. This allows you to save memory, yes, but also prevents you from parsing the content all at once. And because you are writing efficient code from scratch, everything you do will be forward compatible with efficient processing. You don't always need to save on memory. For one, in-memory databases with a log and periodic disk or card sync are an efficient way to deal with frequently accessed data that may need generic methods for sorting, for example. Oh yes, there will be plenty of opportunities to simplify things, but you will know to ignore them in order to protect the efficiency of your code. Oh yes. Two examples of disasters are the Java programming language, which is just too slow to bother with on a slow computer. This isn't really related to JavaScript. And I remember an important government website crashing because it used an XML database, probably with XSLT style sheets, and almost certainly ran on Java as well, though it could have been PHP, I suppose. XML is a beautiful technology, but it does not scale really well. It's not a responsible way of approaching a large database. I'm assuming a company stepped in and not only set up a memory cache server, but also probably replaced the XML database with something that does scale properly without too much effort. Both the memory cache server and the replacement database would have been written over the course of many years by programmers aiming to write efficient code. If you happen to be curious about scalability, know that in a world that uses multiple computers on a network, meaning that by adding more computers it can scale to handle higher processing loads, you don't write the code that executes in your program, but rather post code to a central server called a processing queue. They are really cool to code and very simple to make. And then some 24 computers, which you can simulate with a $30 Raspberry Pi Zero, for example, again, do your own research, check the task out, perform it, usually execute the function that ordinarily runs on your program, and check the result back into the processing queue, which will notify your program of the task's completion and give you all the data. This kind of architecture is set to scale purely because you can just throw more computers at it or queue workers, and thus, without thinking much about it, increase the speed at which the jobs in the queue get processed. And if any of the worker computer fails, you barely even notice. It doesn't compromise anything. It just gets replaced. If you are interested in experimenting with distributed processing, I highly recommend the little and really cool open source ZeroMQ, which will allow your networked workers talk to the queue and the queue back to the program that requested the work to be done. Do not try to become an efficient programmer just to get a good job. The prestigious companies will almost certainly treat you like a nobody. And they will be unwilling to go over $500,000 per year. A good and efficient programmer saves so much money that $1 million per year is a bargain. But incompetents will always hope to cover your abilities with 2 programmers and instead hire coders that have no interest in writing efficient code. Just like you are meant to find your meaning in a quest to become a great being by means of reliable self-education, authentic and hard-earned knowledge, and resulting wisdom, you should also accept the responsibility for building your own company or a startup. You can easily demonstrate to your investors why your systems are superior and earn more, as well as learn more than if you got a job at a prestigious company that considered you a junior programmer. Please. Don't waste your time on hoop jumping and diplomas easily begotten by means of memorization and cramming either. Aim to learn for real, because that is precisely what real life will always demand of you.